So we've talked about standard form a lot. There's another form, and it's known as vertex form. And actually, you've dealt a little bit with vertex form when we looked at transformations. And it's called vertex form because you can quickly identify the vertex of the parabola in the quadratic when it's in that form. It requires that you are good at completing the square. And you haven't really done completing the square since before Thanksgiving. So this may be a little bit of a refresher in terms of that. And there's a little bit of a change to completing the square that we did before that we will do today. All right, but the same general ideas and concepts apply. So first off, let's talk about our different forms. This is our standard form as we've been talking about. Sometimes it will be equal to 0. Sometimes it will be equal to y. Sometimes it will be f of x or g of x or h of x. The idea is that ax squared plus bx plus c is still always going to be the same. Okay, you guys know this form already. Vertex form will probably be new to you. And it's this. Okay. Y equals a times the quantity x minus h squared plus k. So what we're going to be doing in part today is we're going to be taking equations that are in standard form and converting them into vertex form. Now, what's nice about vertex form is, like I said, I can pick the vertex off. Vertex is just h comma k. So when it's in that form, I mean, if you think back to the beginning of chapter 4 when we had to find the vertex, we'd have to go negative b over 2a, then plug that in to find the y coordinate, which you can do in standard form. Okay. But I'm going to show you how to complete the square and go straight from standard form to vertex form without having to find the x-coordinate of the vertex first and that kind of thing. Okay? But before we do that, let's just do a simple, I'll give you one in vertex form, you tell me what the vertex is. Okay? So here's the first one. Here's an equation in vertex. Everything is true over here. Okay? The formula, the h already has a minus next to it, which means the h is going to be the opposite sign of what you see inside. Write that down and then write down what you think the vertex is. Looks pretty good. We have a little bit of an issue. And think back to when we did transformations. Okay? When we were inside, what was true about the way that it moved? Inside with the x, it moved which direction? Right, so if it was negative, then it would move to the right. So it's sort of moving the opposite direction that you think. Okay, so in this case, while some of you wrote negative 7 down, the formula already has the minus in it. So the h is only this. Okay, if it was plus, then it would be a negative. Okay, so in this case, the h is positive because the formula already has a negative embedded in it. So we always basically take the opposite sign inside, which is how that kind of relates to the transformation. We kind of go the opposite direction as that we would intuitively think. The outside stays the same. So my text for this should be 7, 4. Okay, and most of you had that, and if you didn't, you had negative 7, 4, and hopefully you can see how that kind of changes a little bit. Okay? Any questions on that? That's as easy as it gets right there. It only gets progressively more difficult. So let's start to progressively get more difficult. Okay? So here's the problem. We're going to convert to vertex. Here's the equation that we're going to deal with. Okay, for starters. Relatively simple one. Now, if this happened to be a binomial square, I could write it as a binomial square, and I would be done. But we know that this is not a binomial square, because 2 is not a perfect square. Now, when we did completing the square, our first move would have been to move that 2 to the other side. Right? But when we convert to vertex form, I need this side to stay equal to y or f of x. Or g of x or h of x, whatever it is. Okay? This needs to be left alone. So all my work gets done on this side now. And you say, okay, well, if I'm supposed to move the 2 like we do in completing the square, how am I going to do that? Well, here's how we're going to do that. We're just going to slide it on down for a little bit. Kind of pretend it's not there. And we're going to focus on this part to complete the square on this part. So we're just going to kind of ignore this. It's going to hang out over there. Don't forget it. It's still there. But we're just going to ignore it for right now. Okay? Now, continuing with the idea of completing the square, after I move that constant term, what do I have to do next? What do I have to check for? No. No.
The y-intercept.
No. You're just saying math terms now.
Taking out the x.
What has to be true when you complete the square before you do it? Go back and look at your notes. You don't remember. Huh? Nope. Go back and look at your notes. What has to be positive? The x squared has to be actually, what's in front of the x squared? What does it actually have to be?
0.
No. 1. This has to be a 1. Remember, the coefficient has to be 1.
But it already is.
Right. But we still have to check for that. You still have to check for it to make sure it's a 1. It's not just implied. You have to check and make sure because it's not always going to be a 1. So in this case, it's a 1. Okay? So we're good. That's all you had to do is tell me that you understood that you had to check for that. We're going to do one of those. I'll show you in a minute. Okay. Now, because what we would do before, if this wasn't a 1, we had to divide everything by that number. We're going to kind of do that later, not for this problem. Okay? Now, so then after we verify that this is a 1, or we make it a 1, what's my next move? Divide by what? Divide what by what? Okay, think back to when we completed the square. After we made...
6x by 2.
So divide 6 by 2, and then what?
And then square.
And then square it. So we have to take the middle coefficient, divide it by 2, and square it, which gives me what? 9. Okay. Now, what we would typically do when we would do completing the square before is we'd add 9 to that side, and then we'd add 9 to the other side to balance it out. Well,
We're going
hold.
to vertex.
Hold, please. Here's how we're going to think about this. Since we're staying on the same side, I need to add 9. That is true. We're going to add 9 into that. But I can't just randomly add 9 to an equation. So what we do to balance it out, when it was just completing the square, we'd add it to the other side. But what would be another way to do that, to balance it out? If we stay on the same side. What? Minus 9. Correct. Okay?
So we add
So
9
essentially,
and subtracted
right,
9?
because what we've done essentially is added 0, which is changing nothing. However, here's why this is important. Okay? What's in yellow is a binomial square. What's in green is my leftover stuff, which ends up being my k. Okay? So I take the x squared plus 6x plus 9. Okay, and that's my binomial square. So how would I write that as a binomial square? X plus 3. Because before I squared this, I had 3. So this all becomes the quantity x plus 3 squared. And what's left over here? Negative 7. Okay? This is now in vertex form. Okay, so we've done some manipulation. What is the vertex? What is the vertex now? Negative 3, 7. That is correct. It's negative 3 because it always switches the sign from the inside. Because the formula already has a minus in it. So in reality, what I have here is x minus negative 3 squared. Because the formula always is negative, which makes the x negative. You can just think of on the inside, go the opposite sign. Okay? Now, as Harry pointed out before he made that fairly rude comment,
Yeah, Harry.
sometimes the number in front of x squared is not going to be 1. And the way we do it is a little bit differently. And it's more complicated. And it takes a little more thought. So we're going to go through one of those so you have an idea of what that's going to look like. Okay? Like this. Y equals negative 2x squared plus 8x minus 5. The coefficient on x squared is not 1. But we have to make it 1. And I'm going to show you how to do that. All right. The first thing I'm going to do, Andrew, what did you say you were going to do? I want to hear you say it in the context of our school.
What did I say? Oh, excommunicate the thought.
Excommunicate the negative 5. Well, not entirely. We're just gonna admonish it and put it to the side. Ooh, I can't do that. I'm doing two things at once. My bad. I'm doing two things at once. Sorry. It's not wrong. We're doing that, and we're also going to take care of the negative 2 in front of the x squared. But instead, here's the thing. In the past, with completing the square, we would just divide everything by negative 2. Okay, we can't do that now because I can't put a negative 2 on this side. This y needs to be left alone. So what we do instead is we factor it out. So it's going to stay in on that side. So if you think about the vertex form, there's that a in front of the parentheses. For the last problem, the a was just 1. In this problem, what we're going to do is we're going to partially factor. And we're only going to partially factor with these two terms. And then we're going to excommunicate the negative 5. We're going to slide that down and not worry about it. Okay? So whatever number is in front of the x squared, that's what gets factored out because we need to make it a 1. So even if it doesn't go into this number evenly, okay, we take whatever number is in front of the x squared and factor it out. So we treat it like it's the greatest common factor.
Basically.
Okay. Ooh. Okay. So that's what this kind of looks like. Okay. So here's the minus 5 is still just hanging out down here. We didn't do anything with it. Over here now, what we did is I have to factor out a negative 2, which means I have to divide 8 by negative 2, which is where this negative 4 comes from. Okay? And so as you can kind of see, what we're going to be doing is completing the square just in there. Because we're going to turn what's left in there into a binomial square. Okay, questions about how we got to here? I don't want to move on unless we're clear about what we did. Yes?
So say the 8 was a 9, you would still divide it by 2.
Correct. So if this was a 9 and it didn't divide evenly, then right here you'd have negative 9 over 2. So as I mentioned when we started completing the square, is sometimes you introduce fractions that weren't already there, which makes completing the square kind of challenging for some of you. Okay? And that can happen. Okay? In this problem, at least it didn't happen, so we're good. Okay? But if it did, you'd still have to do it. And we looked at an example in 4.5 of a problem like that anyway. Okay? Where we introduced fractions and had to keep working with them. Now, I need to fill this little spot in. So what will I have to do in order to figure out what goes there? Declan? No. Negative 4. So we're only working inside here now. So I'm going to take this negative 4 and divide it by 2 and square it. Okay? And that's how I figure out what goes in here. Okay? So that's a 4. Because negative 4 divided by 2 is negative 2 squared is 4. So I put a 4 in there. Now, here's where you guys will make mistakes over and over and over again, based off of what we did the last time. Your instinct is, okay, then I just need to subtract 4, right? Because I added 4, I better subtract 4. But I didn't add 4. I didn't actually add 4. Why? Why did I not actually add 4? Because it's what? In the parentheses. Which means what is happening to the 4? It is. It's being multiplied by this negative 2. Okay, so I added 4 on the inside, but to the whole problem, what I actually added was negative 8. So you have to be careful, because whatever's inside the parentheses is still being multiplied by that number that you factored out in the beginning. So when that thing isn't a 1, when that leading coefficient isn't a 1, there's another alert that you kind of have to throw up to make sure you know what's going on. So in reality, what we did is I added negative 8. So how do I counter that? What? Plus 8. Negative 8 plus 8. So I'm going to stick it on the end here. Okay, so essentially what I've done, again, like this should be right up your alley, right? All we're doing is manipulating and manipulating and manipulating to make it look like something that we want it to look like. Like that's part of being a teenager. Changing the way things look to work in our favor.
Why did you add it when you said we got negative 8?
Because I needed to counter that negative 8. Because if I just add so that it's 0. What I've done here, here's what we've really done. We've added 0 to the equation. All this work is just adding 0 to the equation because we don't want to change the equation. We want the values to all be the same. But we're manipulating it in a way to make it look differently. Question?
Should it just say the 2 in front of the parentheses was positive?
Okay.
Then would it, on the other end, would be minus 8?
Correct. So what Harry's question was, which is a very good question, Harry. Okay, if this was positive, then what we would have done is we would have actually added in a positive 8. And so I would have needed to subtract an 8 to counter it. Okay? So when you factor out a number to begin with, that's when you have to be on guard. Because it's not as simple as, add 4 minus 4. When there's not a coefficient in front, when it's a 1, then it's easier. When there is a coefficient, you have to be on guard for this and figure out what did I actually add. Because it looks like I added a 4, but because this entire thing is being multiplied by negative 2, what I really did was add a negative 8. And in order to not change the value of the equation, I have to counter that. And that's just doing the opposite. And the opposite of negative 8 is positive 8. So, over here is my k, right? What is k equal to? 3. Okay? Over here now, what is this as a binomial square? X minus 2, quantity x minus 2 squared. This minus 2 just kind of hangs. Okay? And this is where we are. Now it's in vertex form. In this case, we have an a as well. A is negative 2. So be careful. Be careful here. What's my vertex? 2. Okay. Other questions about this problem or problems like this? And you're going to get to practice it today, and you're going to get to practice it Friday as well. Okay. We have one other kind of problem that we need to look at. Question, yes?
No.
Correct. So right here, before I squared it, I got negative 2. So that's negative 2. That part of completing the square is the same. Okay? All right. Go ahead.
So the only point of doing the top part is to get the h.
We're trying to get the binomial squared. Yeah.
But you already have that.
I don't have it here, no.
You said it no with the thing on the bottom line.
Yeah, this is negative 2 here.
Yeah. So can't you just plug it in?
Yes, but you have to remember to add the 4 to the end. Because this can't equal x minus 2 squared unless I have this 4 in here. So yes, you're right that it's going to be a minus 2, but you still have to alter this to make it actually be equal to that. Okay. Actually, I think you did that on your quiz. You didn't add it in there, if I remember correctly. Okay. All right, last kind of problem. The last kind of problem you're going to see is they're going to give you a graph. And they're going to give you the vertex, and they're going to give you a point, and you're going to come up with the equation from there. Okay? So finding the equation from a graph. And then I'm going to put a picture up here that of a graph, and you can take a picture of it. Let's do that now. Here's the graph that we're going to have. Take a picture of that if you want. Sketch it if you want. I don't care. But I'm going to show you how to find that equation from the graph. Here's the thing that's nice about this. We know the vertex. You have to know the vertex. Okay? So we know the vertex, which is what? Negative 3, 6. Okay? Here's the vertex here. Okay? So here's what I have so far. Simple enough. Okay, I've got my general form of a vertex form, and I can plug in the h and k. So remember that sign of the x-coordinate is going to change. The k is going to stay the same. So that's my starting place. Now, what we're really doing here, when they tell you to find an equation from the graph, we're trying to find a. Okay? There's one piece of information on this graph we haven't used yet. What is it? No, we just used the vertex. Negative 5, 2 we have not used yet. Okay? Any point is x and y. So what I can do here is simply plug negative 5 in for x, 2 in for y, and then I will only have one unknown. Because right now I have 3 unknowns. Y, a, and x. If I plug this point in for negative 5 for x and 2 for y, then the only thing left is a. So finish this. Solve for a. You guys have a tendency to make these problems much harder than they need to be. If you follow order of operations, this problem is not that bad. Okay? You guys forget sometimes, because you're used to doing algebra and using properties and stuff, that if you just use order of operations, what do I do first? Yeah, parentheses. Negative 5 plus 3. Parentheses are first. And I'm watching some of you guys distribute the a. I'm watching some of you guys trying to square these. Like, stop it. You're making your life so much harder. Okay? Negative 5 plus 3 is what? Negative 2 squared. Okay? So now it's a pretty simple equation. Okay? So what's a? Negative 1. Okay? So here's what I've accomplished. I found out what a was. So now to put this equation into vertex form, I go back to the top. Actually, I go back to the second line. Because all I really needed here is if I had a, then I'd be done. And I'd have it in vertex form. So that's what I have to do. I have to plug in that negative. Looks like that. You don't necessarily have to have the negative 1. You could have written it like this. Either one of those is fine. Okay? So, Declan said, couldn't you tell it was going to be negative because it's opening down? Yes. But we don't know how negative, right? It could have been negative 4 or negative 3, or we don't know. So that's good. That's a good observation. When you see the graph opening down, you better find out that a is going to be a negative number. And if the parabola opens up, that a is going to be positive. So that's a good check. Yeah?
You got positive 3 because it takes 3 to go over to the left.
No, so it's positive 3 because in the formula it's minus. So in reality what I do here is I plug in minus negative 3. Which makes it plus 3. No, we don't have to do that. When we have the vertex, we don't have to go through completing the square stuff. Okay? Other questions?